So here we have, this is really the square root of 2 to the third. That's what that really says. Minus 2/5, and this again is really the square root of 2 to the 5th. So the square root of 2 to the 5th. So you might see this as your multiple choice. Let me fix that 5. Okay, you might see something like that.
Can you cube it for your square?
Sure. You can make it the square root of 8 and make that the square root of 32.
Okay.
So you can write that as 4/3 root 8 minus 2/5 root 32. That's fine. So Kenny's saying, can't we just cube it, make it 8, cube, and raise it to the 5th, make it 32? Okay, but there's really not much more to do. What we could do right now is what? If we really wanted to?
What's it called?
Break them up. This is really 2 radical 2. This here is really 4 radical 2.
Or we could also do the method that we did in
Simplifying rationals? Simplifying radicals?
no, we did in like a couple like concepts, not concepts ago, but like
Years ago?
what do you no concepts ago, like when we were talking about how we can
Yes.
before they got a calculator, they were able
You
to
could approximate the square root of 8 using the differentials and the linearization. Absolutely, you could do that. But again, if you want to, you can break this into 2 root 2. Okay, because this is really 4 times 2. You can break this into 16 times 2, which makes that 4 radical 2. Again, we did this all in algebra 2. It's got to be, you know, it's got to be memorized, I guess is the word. What are you whispering about? So here, we have... Say again? No, because you have the thirds here. The third and the fifth are different numbers. Making a mistake. Wait, say it one more time.
Because since both the denominator is different, so subtract them, you make them the same, so you multiply 5 for the 8 over 3, and the 3 to the 8 over 5. So you get the same denominator.
He's basically saying make the two fractions the same number.
Oh, I see what you're saying, Karen. I'm sorry, I see what you're saying. No, it's still not going to be 0. The only time you ever get 0 is if the numbers are the same. They're not the same. So you can't get a 0 here, right? Just logically speaking. 2 minus 2 is 0. If those are the same, you get 0. If you wanted to, though, Carrie, you're missing a 3 here, this becomes 24. You're missing a 5 here, this becomes a 40. 40 minus 24 is 16. So you could get a common denominator, that's fine. You can make it 40 over 24 root 2 minus 24 over...
Why did you use
sorry. Okay, you could do that also. Subtract 16 over 15 radical 2. That would be the simplest form as an answer. So if you're doing a multiple choice and you don't see those other answers, there's a good chance you got to keep simplifying. Okay, you could also write it as 16 root 2. Sorry, we went from here up to here. The common denominator was 15. So I multiply by 5, multiply by 5, multiply by 3, multiply by 3. Okay? This becomes 24, this becomes 40. 40 minus 24 is 16 over the 15 radical 2. Okay? It's actually not, though, guys. Honestly, if you did this from start to finish from the very beginning, they give you 2 to 3 minutes per multiple choice. Doing this after doing the whole year, you need to be able to do this in 2 or 3 minutes. It's not that tough. The hard part is realizing what to do here to get this right, and then to say to yourself, okay, I got to distribute and go. But you know what? The answer might be given like this. The answer might be given like this. We don't know right now because we don't know what the choice would have been. But you got to keep in mind that it's not necessarily true that you have to go all the way to the end. What are the problems? 13? Oh, come on, Edgar.
No, because like, the 3 confused me. Because like, if you go up to the top, and they...
I'm going to discourage him because we've done this many times. That's why. I'm going to go through it, but take a look, Edgar. 3 over x squared minus 1 dx, right? Tell me what confused you. I want to know. I really do.
Like, if I brought the x to the -2 up,
Good.
Wouldn't it be able to say if I move it back, like do reverse, wouldn't it could also bring the 3 back down also?
Sure, but why would you ever do that?
No, that's the part that confused me. Like,
Okay. So we learned that when you have a positive exponent in the denominator, you can move it up to the top and make it negative. So if I do this, Edgar,
and if I were to do reverse,
I understand.
if I could like
You could move the 3 down below, but then it would be 3 to the negative 1. You know what I'm saying? Again, if you move the 3, if you move this one down, yes, that's fine, you can. Theoretically, you could put 3 to the negative 1 here and get rid of this. But that's not going to help you integrate. You feel what I'm saying? So think logically here. The only thing that helps you integrate is when you have a power rule here. Now we can use the power rule for this. Integral. Negative 1, because you got to go up a power. Negative 3 is actually going down a power. Remember, what is negative 2 plus 1? It's negative 1. And divide by negative 1. Yeah, and you're going to see the negative 3x, and then minus x. Okay, evaluated from 1 to 2. This becomes just negative 3, x to the negative 1, which, as Carrie just said, we can write as just negative 3 over x. Okay, again, this is really negative 3x to the negative 1, negative 3 over x, and then just plug in your numbers and get your answer. Plug in your 2, get a number, plug in your 1, get a number, and then subtract. So what you end up getting, negative 3 over 2 minus 2, minus negative 3 over 1 minus 1. Okay, again, plug in your upper limit, get a number, plug in your lower limit, get a number, subtract. What do you get for your answer? Negative what? 0.5? Agreed, others? This is going to be negative 1.5, negative 3.5. This is going to give you negative 4 and positive. Yes, very good. Negative 3.5 and 4. Check your numbers, please. You can use your calculator if you need to, but this is 1.5. This is negative 2, which makes this negative 3.5. Minus, this becomes negative 3. Minus 1 is negative 4. That's a plus, really. 4 and negative 3.5 is 0.5. It's positive 0.5. What about the trig ones? How do we do on those? Those are the ones I thought we'd have trouble with more than anything. Numbers 27, 28, 31. Did anybody get 31?
31 took me a while. 10.
Did you get it? What is it? 10. How did you know? Did you look at the table?
Yeah, I took the table later.
Also, what's the derivative of tan, guys? Secant squared. So the integral of secant squared is going to be tan. Because they're inverse operations. Again, we're looking at number 31 right now, people. Number 31. It says, take the integral from negative pi over 6 to pi over 6 of secant squared x dx. Well, the derivative of tangent is secant squared. That's what we learned last chapter or last topic. So the integral of secant squared is back to tangent. So this becomes tangent x, evaluated from pi over 6 to negative pi over 6. So you simply plug in the first one, plug in the second one, subtract the 2. Do you know what tan of pi over 6 is, though? Of course you do. What's pi over 6? What angle? 30. Really? 30. Tangent of 30 is? 1/3. Right, 3 over 3. Okay, again, you got to know these numbers, guys. Again, you got to know these numbers. So here, this is really 30 degrees. So you're doing the tangent of 30 degrees, I'm going to write here, minus the tangent of negative 30 degrees. Again, you can use pi over 6, but personally, I convert in my head all the time. Okay, because I don't memorize all the ones for the readings. I memorize the degrees. This is 1. Because root 2 over 2 over root 2 over 2. 60 is root 3. Do sine over cosine in your head. Sine of 30 is 1/2. Cos of 30 is root 3 over 2. 1 over root 3, which becomes root 3 over 3. That's where that comes from, your answer there. Always do sine over cosine. You don't have to memorize tangent, people. This is sine of 30. This is cosine of 30. They become that. If you rationalize, which you really don't need to, remember we talked about that? You get this. And then negative tan, remember, use ASTC. ASTC. Where's negative 30? Isn't it down here? That's negative 30. Amanda shot the cat, yes. This is negative 30 down here. A smart trick class, which I say yes. Since this is negative 30, only cosine is positive. So you're going to be subtracting a negative. If you do root 3 over 3 minus negative root 3 over 3, it's like you're adding, right? Again, it's like you're adding. Want to add those together? That's what you get.
Would you rather,
Okay.
like,
So it's not 0 here. It would have been 0 if this had not been tangent of negative 30, or if it had just been tangent of 30, which is obvious what you're looking at, right? Okay. Now, I got a question for you guys, and I want you to use logic for a second. Who can come up with an integral on their own? Who can come up with an integral on their own that has different limits in the top and bottom?
did it have to work?
That has different limits in the top and the bottom that gives us 0 as an integral. Got it already?
Yeah.
Okay. Let's hear it. If you got it, that's awesome. Dx, right?
Yeah, dx.
Okay.
From 0 to 4 pi.
Nice work. All right. How do you know that? Tell everybody how you know that.
It's like repeating functions.
It's a cyclic function, isn't it, sine? Take a look. From 0 to 2 pi is that, to 4 pi is that. So this positive area, there's 2 positives, right? Aren't they the same on the bottom? And they're 2 negatives. So what's going to happen to them? They're going to cancel. So he's absolutely right. The integral of sine is just negative cosine. And if you plug in 4 pi, cosine of 4 pi is going to be 1. Cosine of 0 is 1. You're going to have 1 minus 1, which is 0. Awesome job. Logically speaking, we did that. Okay? Again, you cancel this. Hey, guys, that's what real understanding means there. Understanding the correlation.
That's what we're laughing.
The correlation between the area and the actual function. What else could this have been instead of 4 pi?
2 pi.
Or
Any even pi.
any even pi. N pi where n is an even integer. Because if I have 2 pi, it means I'm only looking up to here, and those cancel. If I have 6 pi, I have another 2 loops. 8 pi, another 2 loops. But eventually, you're always going to have the same amount of top as below. What about for cosine?
Over 2.
Okay, let's look at the graph of it.
Does it have to be like every pi? Every pi?
Is it every odd pi? I'm saying odd pi. Oh no, sorry, it's the same thing. Half.
Cosine is the same thing. Cosine is the same thing. Look at the cosine wave, guys. This half here and this half here cancels with this half here, really. This is really a quarter of a wave, right? That's a quarter of it. That's a quarter, and this is a half a semicircle. Quarter, quarter, and the half cancel. Now, Christian, you could have used other limits also. You could have completed the wave like this, realizing that this touches where? Pi over 2, negative. Okay, this goes all the way through to here to 3 pi over 2. So you could have done the limit, or the integral, sorry, from negative pi over 2 to 3 pi over 2. So what I'm trying to get at is this. On the AP exam, there is a good chance they're going to give you trig integrals that turn out to be either 0 or like 1, okay? Where they're going to have answers that sort of cancel each other out along the way. And if you can notice that, you don't have to do any work. If this was multiple choice right now, and you asked me to figure this out, I would just tell you the answer is 0. Because I can picture in my head, from negative pi over 2 is this, that's that half. From all the way to pi over 2 is this half, and those two cancel. So this integral is 0, automatically, by geometry, not by integrals. Okay? Just by geometry. So please keep this stuff in the back of your head as you're doing this. All right. Numbers 27 and 28, you're integrating. Again, make sure you don't forget about that 1. When you integrate the 1, it becomes an x. When you integrate the 2, it becomes a 2x. And then the cosine and sine, you have to integrate those separately. No, not yet. Unless it's a really emergency. Like, can you hold it for like 10 minutes? Okay. If you can't, and whenever you have to go, if it's emergency, you go. Here, we're looking at the average value of the function now. New topic, it's at Lowe's. Okay, we're looking at this, what I want you to read last night. The average value of a function. This is extremely important that we go over this. Okay, that's what you're supposed to read in the last 2 nights. So, let's say for a sample. Let's say I've got a container. Okay, before we get to math, let's use logic. I've got a container. If I started filling it up with water, it's going to look all turbulent. The water is going to fill it up, it's going to flow, but eventually what happens to the water? It settles out, doesn't it? So there might be like little ripples in the water at some point, but over a long period of time, isn't it going to just settle out to be flat? Okay? So here's what I'm going to think about. The amount of water you put in here, is it changing at all when it settles out? No, it's not. Like, granted, we could say it's evaporating, but imagine there's no such thing as evaporation right now. The amount of water you plug in here, say the volume is like 2 liters. Over time, it's going to flatten out. The volume is still going to be 2 liters, right? So, in a 2-dimensional world, this is 3-dimensional, but in a 2-dimensional world, this area, isn't it the same as this area, really?
Yeah.
Again, in 2 dimensions. In 3 dimensions, we know the volumes are the same. But in 2 dimensions, those areas are identical. So what can I say from this is the following. If I have any curve, I can find a flat line from A to B. Here's B, here's A. From A to B, I can find a flat line such that the area will be the same as that area. Again, if I pick a random line here, the red area is going to be equal to the blue area. And it doesn't look like it works that way, but think about the example we started with. When I pour that water in, it's going to look all ripply, but it settles out, right? And the volumes are the same. Thus, the areas are the same. Jasmine?
So can you put a line anywhere?
That's what we're trying to figure out, where that line is. So I'm picking an arbitrary height. Call this arbitrary height C, if you would like. We want to figure out the value of C that causes this rectangle to be the same as this weird-looking shape. Okay? So that's our goal right now, is to figure out what must the height of the function be to give me the same things. Okay?
Doesn't depend on the curve also?
Sure.
So
It
when
depends on where you
Max.
start, where you end, if it's cubic, if it's squared, all that stuff.
The max, I'm just saying ripples in a way.
Yeah.
Because it is sort of like a ripple, but the max ripples have to equal like the same amount of like space for it to be considered like all the area. What I mean is like you see how like we're looking at like, the one on the bottom, like with the arbitrary line that you put, it's like saying the one on the line on
Yes.
the hump on top.
The extra area yes, absolutely.
Is that what-
The upper area here counteracts the lower area here. That's what I was trying to show you with the red line there.
Yeah.
Now, if we had 3 waves, so here, let's take a look at this. If we had something like this, okay, like that, and I drew a random line through almost the same spot, which was here. If I draw a random line here, it's not going to be the same, right? Because there's 2 extra areas up top and only 1 down below. So the area of this rectangle wouldn't work out. So maybe I'd have to actually move it up a little bit like this. Because now I've got a bigger area down below and 2 small areas up top that will counteract that. Okay? So what we're doing here is we are constantly trying to figure out what is the height of the function that will give me a rectangle that has the same area as my curve. So if you want to write this in words, here's what we're figuring out. Any random curve, we want to figure out the area of this curve. When will it be equal to the area of this box? From the same limitations, from let's say A to B, figure out the height of the rectangle. That's what we're trying to do. Okay? So can we replace this weird-looking curve with 1 rectangle? That's all we're doing. Now, if you read last night, you noticed it was called the definition of the average value of a function, right here. That's all it is, and that's what this is. This is indicating the average value, because the function fluctuates. Let's say for now that this happens to be 10, this happens to be 12, okay? I know that the value of the function here is 10, then it's 11, then it's 12, 11, 10, 9, 8, 7.5, 8, 9, back to 10, back up to 11. So doesn't the function's value change? My question to you is, what is the average value of the function? Well, that's this right here. This C value, whatever it turns out to be, say the value is 11 or 11.1 or 10.97, whatever it is, this is the average value of the function. Remember, the value of the function is the height of the function. So we're finding the height here, really. Okay? The way we do that mathematically is by using our formula.
You ran.
You missed a lot, I'm telling you now. Okay, we went over where this all comes from, please. So here, this is our formula for area function. So now we're getting into the math behind it. So if we're given a random function, and last night you were given this function at the bottom. We're not going to use the same exact example, but we'll change it up a little bit. Let's say we're given the function f of x equals 2x to the third minus 5. And I want to know what is the average value of this function. Example, yep. I want to know, this was our formula, guys. I want to know what the average value of the function is, or that height. What would that height be that we were looking for on the interval from -3 to 5? From -3 to 5, what will the average height be of this function? Or what will the average value be? So again, we're looking for that rectangle. What is that rectangle going to look like? So all we have to do is this. We take the integral of the whole thing, you get an area, and then divide it by b minus a. b minus a is what? The length of the what? Good, which in our case for the rectangle we would call that the, what is it? dx or delta x, very good. Okay, dx or delta x, that's what we're looking for here. We're looking for that interval length or the width of the rectangle, and we're saying, what will the height be of this rectangle so that we get the same area? Okay, so again, our shapes, we're looking at something like this. If I had a general function like this, what is a function that we can make up that has the same area? So for our example, let's start by plotting. Think in your mind what this is going to look like. What does a cubic function look like? Yeah, what is that called?
Like a sine thing, but
Like a tangent. Okay, tangent is really this. That's tangent, but we're looking like this. Okay, so it's like a tangent that has a min or a max, kind of. Okay. Now it's 2 in the front, which means it's going to be steeper, and it's minus 5, which means it's going to be below the axis. So if I were to draw this actually like this, I might draw. Let's see what my roots would be.
There's a point in minus 5.
5 over 2, cube root of 5 over 2. Is it going to be above or below? Negative 1 is going to be negative 2 minus 7. So down here, I'm guessing it's this, but I don't think that's right. Anybody have a calculator? Want to graph that real quick to see what it actually looks like? I feel like that's not right. I don't think there's an inflection point on the axis there. Or, sorry, a tangent on the axis there. That's why. All right. For some reason, I was thinking that was there. Because it's cubed. I was doing fourth. If you had a fourth order here, and you were moving it over, you would get plus or minus the roots. That's why I thought there were 2 roots there. Okay, so here, okay, it looks something like that. And we are trying to figure out what is the average value of this function between negative 3 and 5. So between, let's say, negative 3 and 5, wherever that is. Is 5 to the right of that? Is that correct? If you're looking on the calculator?
Yeah.
Okay.
The roots are like this.
So we want to know.
Well, not really. It's like 1.5.
Okay. We want to know the overall area of this. Can I replace this with a rectangle that has the same overall area? Or what is the average value of this height? Okay, so let's go ahead and look. Let's take a look here. Let's say the integral, again, of f of x dx times, in the beginning, 1 over b minus a. Okay, 1 over b minus a. So here, I want to take the integral. What were my limits? From negative 3 to 5, right?
Yeah.
Okay, negative 3 to 5. If I didn't put that, let me go back, and if I didn't? Yeah, I did, okay. All right, now the integral of this becomes x to the 4th over 4, but there's a 2 over 4, which makes it 1/2, really, again. This is really 1/2 x to the 4th. Again, x to the 4th over 4, minus 5x from 5 to negative 3, all of this, times 1 over 8. Again, don't forget the 1 over 8 in front. 5 minus negative 3 is 8. Now, I need to evaluate this first. This negative 3, by the way, goes up with the integral. I need to evaluate that first. Get your answer, and then just divide it by 8. So, let's go back for a second. We'll get the answer in a minute, but let's think also. What we're really doing is this. We're finding the integral, and then we're just dividing by the length of the interval. We're finding the integral and dividing by the length of the interval. Again, look at this logically, people. This is the integral over here, and we're multiplying by 1/8. 8 is just the length of the interval. 8 is the length from here to here. Oh, sorry, all the way to the end, all the way to here. That is a distance of 8. So we are trying to find the whole area and divide by 8.
So basically, it's like if you're given the area and you like trying to find the
Sure. You calling that the length? Yes, then call that the width. Sure, or the height, either way. I will call it the height for now. Okay? Call this the height.
This is the one add z into it, and then it's going to be.
Yeah, I know.
What do we find when using this?
You are trying to locate the location of the actual y value. So watch, let's keep going here. Let's keep solving and we'll see. So here, when you plug in the 5 here, leave the 1/8 out in front. We'll do that at the very end. Plug in the 5 here. We're going to say 1/2, 5 to the 4th, minus 5 by 5. Okay, that's one of my parentheses. Subtracting Okay, again, what am I doing? I'm taking the 5, plugging it in 2 spots, getting a number, that's over here. I'm taking the -3, plugging it in 2, get a number, that's over here. Okay? What do we got?
625 over 2.
The whole thing?
Oh, no.
Sorry. This is 625 over 2?
No, the first part of that.
Okay, because that's 5 to the 4th, 625.
Over 2.
625 over 2 minus 25. Okay, so I can think of it this way. 625 over 2 minus 50 over 2. That's how I'm going to do it in my head. Right, because aren't you really subtracting 25? Isn't 25 50 over 2? Again, guys, I know you don't just think logically. 625 over 2. And this is really 25. Think of that as 50 over 2. Okay. Give me the decimal. For the whole thing or for this right here, Jasmine?
623.
For this?
232.
This is going to be 312.5 minus 25. 287? Again, if you don't want to do this the way I did it, guys, just call that a 25, please, if that confuses you. Over here, -3 to the 4th is negative, or positive what? 81. Those are ones you should know. 3 to the 4th is 81. So this is going to be 81 over 2 minus a negative, which is plus. Again, minus negative is plus. 81 over 2 is 40.5. So 46, no, 45, 55.5. Jeez. Lose my mind. Minus sign still here. Big parentheses. Still got a 1/8. Okay, subtracting. 232. An eighth of that is 29. All right. So 29 is the height of the function that will counteract this. And here's what I want to do. I'm going to show you this geometrically now. So what we're going to do is the following. Open up GeoGebra. Where is my...
Divided by 108, or divided by 8.
Why did I divide by 8? Oh, why did I put half?
Yeah.
I said 8, but I wrote half. I don't know. So the original function was y equals 2x to the third minus 5. Is that right? The original? 2x to the third minus 5. Okay, there's that curve now. I'm going to zoom in a little bit. The other function is y equals 29, which clearly we don't see anything right now because it's above the graph, right? It's all the way up top. So what I want to think to myself is, I want to get all this on the graph. So I'm going to say to myself, I'm going from -3 to 5, right? From -3 here to 5. So I'm going to write x equals -3, and I'm going to write x equals 5 here, just to show me where I'm going from where to where. Do we all see that? There's the -3, there's the +5. Okay, that's the actual curve. Where's the 29? It's all the way up. So I'm going to zoom out for a sec and take a look here. And I'm just going to see that it's going to look really messy right now. And I want to get up to the 29. There's the 29 up there. I'm going to see how low this one goes. It goes all the way down to like -60. So I'm going to go from -60 up to 30 for my y. So my y-axis from -60 all the way up to y max of 30. And on my x-axis, I'm going to go from, we went from -3, so I'm going to say -4. And I'm going to go one more over there at 6. Okay, and what we're going to notice is this. If you find the integral of this, okay, and then you find the integral of, it's going to, we got to go up a little bit higher, guys. Sorry. It's my fault. I got to go up higher. Where does this intersect up here? Let's take a look. Ooh. It's going to intersect all the way up at, oh my gosh, 240. So I'm going to go to 250 then. All right, that's much better. Now, what this means again, if you were to fill up this rectangle here that we just wrote in, if you filled this up with water or some sort of a fluid at all, okay, the amount that you would use to fill that up is equivalent to this amount that I'm about to shade in minus this amount over here. That's what we're trying to figure out right now. Again, if you took the area that is above and the area that is below, because that's what the integral is, and you subtract them, remember the integral you think of below is negative. If you took the green minus the red, you'll get the blue. That's exactly what we're doing in words, okay? But you have to know how to do it with equations. So the 1 over b minus a part, you're finding the average value of the function. So this means between negative 3 and 5, the value of this function constantly changes. First, the value down here is around negative 60. Then it's around negative 50. Then maybe negative 20. Then eventually it gets to the negative 5 that we had in the beginning. Then the value of the function jumps up higher. Then it goes all the way up to 150 until it gets all the way up to around 250. What is the average value along the whole thing? Well, there's no way you could figure it out without calculus. Try it. I mean, sit here all day. You're going to say, all right, well, it looks like this appears more times than this. How do you know what the average value is? What would make you guess 29? Nothing would. But from calculus, we're able to determine that the actual average height of this function is 29. So we're showing now what is the average height of the function, which is the same thing as saying what is the area of that rectangle.
That's just the average height between negative 3 and 5.
Correct, correct. If we look at the function between a different limitation, it will change. Okay, it's going to change if we do that.
Oh, you can't get out.
So what's like the difference of what we were doing and this? Like, is it the same thing?
Doing one yesterday or doing?
Like the concept. Like we're doing the same stuff.
We're still using the integral, but now we're putting the 1 over b minus a in the front. And what that does to us is it allows us to divide by the length of the integral and get the average height.
That's the only difference.
It's the only difference now. It's called the average value theorem. That's what we looked at last. You were out on Tuesday. When I gave you the reading, that's what I wanted you guys to maybe look at. And it was in the reading already. Okay, it was in the reading there. Now, we have a lot to do still. Okay, there's a lot of stuff to cover. What I want you to do is practice this now. Tomorrow we're going to start something different, but we need to practice this to make sure we get it right. It's pretty straightforward because it's just arithmetic. Okay, it's all you're doing. You're going to integrate, and then after that you use arithmetic. Practice one on your own.
Which one?
I'm going to make it up right now.
Feel that.
Still,
How
like,
do you feel? Exactly.
here.
By the way, did you say all that?
Huh?
Right now?
What? Oh, no, you didn't.
This here.
He said logic. He was going. Chris. There. Put her down. I don't know why anybody would like draw that dress.
You
And
know,
make down.
Maybe they just ran out of articles because they have like so many.
Yeah, the new one's just a little weird. If you open it again, it's hard to open. Here. It's called Johan.
Try this one, please. On your own, try this. Tell me what you get as your answer, please.
Okay.
Do you need a calculator here? Probably not. You're going to have to cube stuff. You probably won't need one. Try without it. If you really need one as you're going through, use a calculator. You might not need one for this stuff. Just try your best, okay?
If I don't know what that's
If you don't know what your best is,
I can't do my.
then you got to figure that out.
Dang.
Self-awareness, my friend. You can't know other stuff unless you know yourself.
That's not true,
It's
actually.
fine. Of course it is. If he doesn't know his own limitations, how can he know what he can do on the test? You don't know your own limitations.
I mean, like,
I'm not concerned. Find the average height of g of x on the interval, negative 2 to 3, if g of x equals the following. Now, it doesn't even look like a calculus problem at first, because you don't see an integral sign or any of that. You got to start by using the formula we used. So you use your 1 over b minus a times the integral of a to b of g of x dx. You use the formula that you had and solve. See what you get. If you want to estimate, you can try by estimating. You could start by looking at the graph and say, oh, what might be the average height? Take a guess. Take an idea of what it would look like.
It's always A to B.
Whenever your interval, guys, it's a good question, it's always a to b. So a is negative 2, b is 3 in this case. Always a to b. Always a to b.
okay. Other numbers. No, it's just like they're all over. It doesn't divide itself.
Great.
The thing is this, and here's the hard part. You're always going to have at least a quadratic. Because if you had a linear function, finding the average value is very simple. Because it's
Yeah,
a
like-
line, and then you can set up special triangles and similar triangles to find it. So you don't need calculus for anything that's not, anything that's linear or below, you don't need calculus to do it.
I need calculator. No, just because I can do 2 steps in one.
This is correct, absolutely, yep. 3 minus 2 is fine, good. And now you can something. But what I wanted to show is on the test, you're gonna do this, a line there, and put your limits at the top of the line. Put a 3 there, and you get 2 down there. Now this tells me, take 3, plug it in here, and run it through it, then take -2, and run it through and subtract. So take this first, get an answer, and you plug in those 2 spots, and take this, get an answer, and those.
What's 54 then?
18. 54 over 3?
But
No, look at, guys, you have 3 cubed up top and 3 down below. Just cancel one of them, you get 9 times 2, which is 18. Right? Did you
Yeah.
cube a 3 anyway?
Exactly, sure. Well, that's me, it's just like, conservative, like that, right?
Yep. Absolutely.
No, just-
So you're gonna find this one first, then
Yeah, that's what
and
it is.
subtract the answer, and then the end divide by 5. Remember, don't forget at the end, you gotta divide by 5 or multiply by 1/5. It's the last step there at the end.
I hate it when you never see what you're doing.
Your book, if you want to write this down, does a good job of explaining this on page, well, from page 286 to 287, the very bottom of 286. So in case you want to see a picture of this too, okay, in your textbook. Yes, sir. I would do that, I absolutely agree. That's what I was telling them. They would try to figure out 3. Well, they just cancel the 3s, it's 2 times 9, it's 18.
18 minus 21.
Plug it all in one step, or is it just 3?
Huh? Yeah, I just said 10.5 minus.
Or switched. Doesn't matter. Here,
Negative
listen.
16 divided by 3.
You're just gonna switch. Yeah, so you're gonna flip flop these. So this is gonna be 3 up top and
I'm
-2,
not
3, -2. So these are gonna be opposite of each other. It's gonna be this one minus this one now. Yeah. You just put a negative sign in front of it.
Christian, 16 divided by 3 is 5.3 or no?
That's what I'm saying.
Huh?
Put the negative before the parentheses, though,
Yeah.
not before the 2. Because you're negating the entire quantity, right?
5.3. Yeah.
Oh, which one from 3 did you get? You got that from 3? And you got that from that one? So you have to do 10.5 minus negative 13.3, and then divide by 5. Multiply by 1. You always, again, you always do this number, whatever you get here. Okay, whatever this number is here.
Oh, God.
Because all the numbers are 10.5.
I don't, but my, for some reason, my mental math sucks.
You subtract whatever you get from finding that number.
It's like
Negative
-16.
16. What do you got?
For the answer?
That's negative 3.2? No, 4.2.
There's a 1/5 there.
What did you get?
I got, you're right.
Negative 4.2, right?
Yeah, so I didn't make it negative.
And then,
That's my answer.
so you got
This
this
range
range
answer.
from
Let's check to make sure it's right.
here.
Yes.
You didn't multiply it by the 1. So you get 1/5?
Yeah, you keep 14.6.
For the,
So you got 14.66?
yeah, for that side.
I got 14.7. Oh, I'm thinking by, wait, what do you
Either
get?
way, the answer's gonna be like 5 points.
It's 4 point something over 5.
Answer is.
One paper again, nice. Right? It bleeds through like
Wait, I
nothing.
got over 2.
Which is like,
Yeah.
You got over 2. Answer.
Thank you, Gary.
Yeah, Christian, what's 1.2 about? Good? Just wanna see. Christian, what'd you get? I got negative 0.81. Fine, No, it's 4.
You ready for it?
Okay.
Any?
Yeah.
2 for dismissal? You done?
Yeah, that is.
Thank you for the message, sir.
So you should go try that again.
Here's one. Screw in the middle of class. You're not.
Anybody?
Wait, 3, 2, 3.
Carrie, I don't know what I would do if you weren't here today.
No, it's your answer.
I keep making a mistake. Oh, Carrie. Well, you too, Carrie. You want to feel special?
No, I thought you were my hand. Like, what did I do? That's what
I got 4.76. You got 4.03.
I got the 15.
Okay, Johnson, what did you get?
-0.83.
Negative 0.83.
Yeah,
4.76. Christian? 14.66. Karen?
Oh, the whole thing?
The whole answer, guys.
0.85.
0.85?
Yeah.
What'd you get?
Negative.
0.832.
Negative 85.
It's probably, let's go through it. Let's just make sure. Just watch your steps along the way, people. There's a lot of room for error. There's a real lot of room for error. So, as we noticed, this is going to be 54 over 3, which is 18. You could also simplify easier. This is going to be 27 over 2, which is 13.5. This is going to be minus 21. This is going to be negative 8 times 2 is negative 16 over 3, which is negative 5.33. This is going to be 4 times 3 is 12 over 2 is 6. And this is going to be plus 14. Negative, negative.
Negative.
It was negative 7, negative 2, right? Go back and look. Oh, what do we got? Negative 3 is 10.5.
I got negative 0.3. That's my fine.
So that's mine.
No?
No, you got.
Yeah, that's what I got.
I'm just doing it this way, Carrie. These give me a net of negative 3, don't they?
Yeah.
And negative 3 and 13.5 is 10.5. Okay?
And that's plus negative.
For 5 words, I got 3.22.
20 minus 5 is going to be 15, so 14.6 repeated. Okay? I'm combining all the terms, guys, all three. I got negative.
Okay, I got
Negative
16 for that.
0.83.
Wait, hold up.
I'm confused.
Hold up.
No, I know.
You divide it by 5.
Yeah, you divide, you get out.
How are we getting a negative, though? Oh, duh, because it's negative there. My bad.
Got 3.25.
Yeah, I got 3.
Negative 0.802.
What, wait,
No?
yeah, I just remember.
Negative 0.83.
How did you get that?
You got 3
How did you
repeating?
get 14.6?
Oh, it is, you know what, I'm sorry, because I estimated, guys. I use this as 0.6. Sorry. I use this as 0.6.
I got
So you're going to get 3's repeating?
We did like 0.6666.
Yeah, that's fine. I estimated that to be 14.6 in my head. It really is 0.3 repeating. This is going to be, right, when you subtract these two numbers, this is going to be 1, and then 3, 3, 3, 3, 3, repeating afterward. Okay, that's what I left out this 3 repeating here. All right, here's what I want you guys to do tonight. Practice.
Wait. Yes.
Yeah.
Beautiful.
Now when you're ready.
All these actors that we see.
Yeah.
How did you get 4?
Oh, look at that over there. That's really pretty legit.
I did, right? We were kind of.
It looks legit though.
You know what the weather's gonna be like tomorrow? It's gonna be like this.
It's gonna be rainy and decaying.
Yeah, you are.
I know, but what day is it?
Tons.
What in the world is
I did not have problems with this.
Fungus. Something's growing on the fungus.
I'm in the section, but there's no.
Oh, really? Really? Oh my God. You must be blind if you can't see me.
Wait.
Why would I lie in my own book?
I'm just going to give you my own problems, guys.
Something is minus 14. Because it's 7, minus 7x. 2 possible or 3 possible? Oh, okay, okay.
You're like that?
She's second motion too.
I know, so. Is there on Facebook? A few minutes. Find the average value of. This is your homework, guys, for tonight.
So you're gonna knock adults or you're gonna poke your head?
You have to knock.
Thank you. What's up? For your what? Your books? I'm confused. What are you asking for? Is it back there?
Oh,
Okay.
I thought you smelled I think I should have mentioned when he goes back. I wouldn't know what to write.
Now, here's what I want you to do tonight, really. First, find the average value of these three. There's 3 problems. Now, what I want you to do is try number 3. After you get the average value, look at it geometrically and try it. Because this is a line, isn't it? So if you want to know the average value of that height of the function, you can do it with geometry. You don't need intervals. So later on, do these 2 normally, but you're going to see that this is going to be a line, like this. It's going to be a y-intercept of 1. So you're going to have something there, a y-intercept of 1, a height of 5. From 0 to 4, and if you see you have a trapezoid here, I want to know what the average height is of that trapezoid. Try it geometrically also. Do it all regular, but try and look at this and see what you notice. And we'll talk about that tomorrow. Now, one other thing I want you to do is this. Notice, when we solved the last answer, we got, what was it, negative 0.803 or 833, right?
Yes.
That was the average value of the function. That was the y value. That was the y value. So make sure you write that down when you do these. Again, that's not telling us the location on the x-axis. That's just the y value. If I go back, I want to show you one last thing. Look at this. If I ask you this next, and this is a tough question the AP exam asks. If they ask you the average value, and then they say, at what location does the function take on this average value? You have to look for the intersection. Keep that in mind. If it says, the average value is 29, but if it says at what location does the function, the cubic function here, take on that value, what you're really looking for is the intersection of these 2 objects, right there, A, which in this case, the location is about 2.5, as Karen said, but the height is 29. Keep that in mind, people. Keep that in mind.
Look at trapezoidal move.
So funny.